Change now. Okay, so I have, hello guys, you're welcome to Chemistry Hangout. I want to believe you're doing fine. I want to believe you are doing well. If you are just watching this YouTube channel for the very first time, this is Chemistry Hangout, and this is one of the best YouTube channel as far as chemistry and science content is concerned. If you are writing chemistry or alternative B Waec article, then there is no need for you to be afraid. I've gotten a lot of DMs, I've gotten a lot of calls on this very practical. Though I have been very busy, you know, we are still preparing for another exam again, and based on a lot of things I'm doing, okay, I've been very, very busy. But you know, a lot of people have reached out to me, and I've promised that I will be shooting a video as regards the alternative B. So if you are doing alternative B, please, I want you to pay maximum attention. The practical is very simple, okay, very simple, but a bit technical. So I want you to pay maximum attention, and I'll be covering. A lot of people have sent me questions to check if it comes out this way, how do they do it? Then I'll be explaining that. So I want us to be very, very attentive. However, please, I have said that severally on this channel. We are not saying this is 100% of what is actually coming out on that day. You know, I've been saying this, but a lot of people say that's how you used to say. And at the end of the day, we'll see that it's very close to the question. The reason is because we try to do our due diligence and observation based on, you know, records, Waec questions, and try to study them. However, we are not guaranteeing that this is an 100% question that will be coming out on that day. But I will always say something, and I'll keep saying it. If you are able to listen attentively to what we actually do on this channel, then you should not find the question difficult. So today, I'm going to be taking you through the practical. I'm going to do the practical. I don't want to waste much of our time. It's a very simple practical. I will just do the titration once for us to get the volume of the acid used, okay, for this very particular titration. It will guide us in our various centers. For educators, to science educators, chemistry educators, it will also guide us in our various centers. So let's get started. So this is the predicted question. That's a predicted question. D is a solution containing 4.98 gram per dm cube of triazonitrate 5 acid. E was prepared by diluting 50.0 centimeter cube of a saturated solution of sodium carbonate at room temperature to 1000 centimeter cube. Titrate this, you know, this is just the normal titration. If you are used to my channel, you know we are always wanting to do this. So let's get started. Let's see how the titration is going to look like. What is our average volume of acid like? What is it going to be like? So let me quickly do this. I'll just do it once so that we don't waste much of our time. I'll do it once, tabulate my readings, then I will solve this, then I will chip in something that, you know, Waec these days are trying to diversify. So the question can come in a lot of form, but we are going to tackle it. So let's go now. Let me pipette this, which is my base. Okay, so this is my base. Okay, running it into my conical flask very quickly. Okay, good. So very important. I've filled my burette already. So let me remove my funnel. I've filled my burette. I said I'm just doing this once for us to just get the, you know, initiative of, okay, more than 0. Okay, more than 0. Okay, so let me 2 or 3 of these. I'm using 2. Okay, can you see? Changing the color now, then I can titrate now. Can you see that now? Very clearly now. Good. Can you see that now? Can you see the color change now? Okay, so I have 25, 6, 7, 8. So 20.8. Can you see? Can you see the color change now? Very quickly. So I'm just doing it once so that I don't waste much of our time. So let me quickly tabulate my readings, having known. So let me do my direct readings. Okay. Then I'll just have. I want to have my rough. Okay. In centimeter cube. Okay. My rough in centimeter cube also. Then I'll just have. I want to do just for first and what and second. Since I already know the average volume I will be using. So very quickly now. Okay, please don't forget all those things. They are very, very important. Very important. So my first is my. Then I can have my final readings. Okay. My initial readings. Okay, so I have like this, I have like this, then I have volume of acid used. Okay, so let's come. So I already gotten my average. I want to believe that is clear, so tabulate. Please tabulate your readings. Very, very important. Okay, so from here now, very important, our indicator, that's methyl orange, you have always said that. Then our volume of pipette, please let it be stated, that's 25.0 centimeters. Because in the question, they said 20 or 25, but we actually use 25. So, very important. I already understood the average I'm using based on the titration I did. So, my initial can just be this so that I don't waste my time. Do you get that? So, my first, since that's the average that I have, so I can just have here 20.80 according to the titration I did. So, it changes the color at 20.80. So, I can have it to be the second also. I don't know if this is clear. So for my rough, most times you don't use it. Though in titration, if the rough is closer to our titrations, we can use them. But in most cases, you don't use them. So since I know I'm not using them, I can just, I can just say this is 21.00. You can see it's a bit far from them because I know I'll not be using them. So that's not a problem. So from there, I have 21.00, right? I have 20.80. I have 20.80. Do we understand that now? Okay, let me erase this. There is no need for this one again. So there's no need for. I want to believe this is clear. This is what I got when I did the titration. Okay, so 20.8, 20.8. I just have to, this can be lower, this can be higher, depends. But this is my bone of, this is where my area of focus, since that's what I'm doing. And in your sentence, don't forget, some of you love to do raw first, second, and third. Fine. So you can have first to be 20.80, second to be 20.80. If you want to do third, it has to be closer to this. So probably maybe 20.90 or 20.70. Anyone is fine. I just had to use this. It's perfect. Okay. So from here, I now want to calculate the average, according to the question, I should calculate the average volume of acid used. So I want to calculate the average volume of acid used. So I'm picking these two, right? So I will have 20.80 plus 20.80 divided by what? 2. So that will give me 20.80 centimeters. I want to believe this is clear. So this is very clear. So that's just the titration. It's just a normal acid-based titration. So it's a very simple one. But the questions can be technical, and that's why I'm doing this. So please pay attention to it. Now look at this. Let's not come back to the question now. So we are solving now. We have gotten this. Let's come back to the question. They said, calculate the concentration of D in mole per dm cube. Calculate the concentration of D in mole per dm cube. Now listen. If you are doing alternative B, listen. Ideally they will write A and B. The normal acid-based titration or the normal, question you used to see, you will see A and B. But because For alternative A, they have used A and B, while the salt analysis they use C. I don't know if you are getting that. For titration for alternative A, they used A for the the acid or the redox, anyone. They use B for the second one. While the salt analysis they use C. So that's the reason why for you that you are doing alternative B, you now continue from what? D. So this will now be D. This will be E. The salt analysis will now be F. I don't know if you are getting that now. So in your salt analysis, you see F is an inorganic salt. You are not going to see C because alternative A I've already used. I don't know if that is clear. So that's why you have to do a little bit of adjustment if you are writing this, because there is no A, B. It is D and E. I want to believe that is clear. So I'll be doing little adjustment to that. So very important. They will give us the equation of reaction. I think I forgot to write that. They will give us equation of reaction for this. Let me write it here so I can start my calculation from there. So the equation of reaction. Equation of reaction. So since this is triazonitrate, that's HNO3. Let me write that. NO3 plus sodium carbonate, that's Na2CO3. That's aqueous also. And that will give us what? NaCl plus H2O plus CO2. This will be gas. This will be liquid. Right, so let's balance the equation. Sodium is 1. Sodium is 1 here. So let's have 2 here. Let's have 2 here. So let's see the equation is balanced now. Although they might have done all this for you. So hydrogen is 2, hydrogen is 2, balanced now. Nitrogen is 2 here. Sorry, NaNO3, sorry. NaNO3. So let's write the equation of reaction now. So the equation of reaction. So let's get the equation of reaction now. So we have HNO3 aqueous plus Na2CO3, right? So that will be aqueous also. Then we can have NaNO3 plus H2O plus CO2. So this will be aqueous. So the liquid. They would have given you all this. There is high tendency to give you this. There is high tendency. So sodium here is 2. So we can have 2 here. Okay. So hydrogen can have 2 here. So let's see if it is balanced now. Hydrogen here is 2. Hydrogen here is 2 balanced. Nitrogen here is 2. Nitrogen here is 2, right? Nitrogen here is 2 balanced. Oxygen here is 6 plus 3. That's 9. Oxygen here is what? 6, 7 plus 2. That's 9. So I think that should be balanced. Sodium is 2 here. Sodium 2 is 2 here. Carbon is 1. Carbon is 1. Balance. Okay. So that's the equation of reaction for this very particular titration. So then I said, please follow the calculations. I'm not saying you should cram this. Understand these things so that when you enter into the exam hall, you will be able to do all these things. So follow the calculation. Understand there might be a twist in the question. Please. So get the way I'm solving it so that on that day when you see likely questions like this, you can solve it. Please. Very important. So concentration of D in mole per DMP. Please note all these things. Concentration of D in mole per DMP. Let's go back to the question. Of course, ideally they will give us Na, all these atomic mass will be given, this is 14. Which other one? Hydrogen is 1, oxygen is 16. All these will be given. So now look at this now. Concentration of D in mole per DMP. Let's go back to the question. What is D? Can you see they're giving us D in gram per DMP? Now they want us to get it in what? In mole per DMP. Very simple now. So let's go now. Question 1. Concentration of D in mole per DMP. Okay, so since it's in gram per DMP, we know that our mole is equal to what? Our mass over molar mass. I want to believe this is clear. So what is our mass in gram per DMP? Is given already. Our molar mass can be calculated. So let's calculate for triazonitrate. That's HNO3. Okay? And then this will be what? 1 plus, it's given already, nitrogen is 14 plus 16 times 3. Right? So our HNO3 is going to be what? 15 plus, this will be 48, right? So our HNO3 is going to be what? That will be 63 gram per mole. I want to believe this is clear. So from here, let's plot it here. So we have mole is equal to, what is mass? That's 4.98 gram per dm³ over, this is 63 gram per mole, right? This will cancel this. Can you see that now? So our mole will be 4.9. Okay, let me have my calculator. So 4.98 divide 63. 4.98 divide 63. That's giving me 0.0790. So 0.0790 mole per dm. This is clear. Very clear, right? Very, very clear. So now let's move on to number 2. Number 2, they said amount of HNO3 in the average volume of D used. Please note this. There is a difference between concentration in mole per dm³ and amount of that very particular acid or base used. Get this right. I've done all these things on my channel. You know, a lot of students will not watch all this video. When the exam is now fast approaching, that's when you'll be running a task scatter. You know, you just put yourself on unnecessary pressure. These are things you are supposed to have watched. We have a lot of videos on this channel on titrations. Sometimes you need to watch all these things to understand how we do this. So, amount of HNO3 in the average volume of D used. There is a formula for that. Please, when you hear amount in moles, there is a, so we need amount of HNO3, right? In the average what? Volume of D. You know D now is the acid of D used. Can we move on? So how do we calculate the amount now? There is a formula for that. Concentration times volume. I've done this a lot on my channel. Now, concentration times volume. I'm not going to divide by 1000. Why? Because the volume here, you know, I'm doing for D. If you look at the average volume of D, is in what? Is in centimeter cube. I don't know if you are getting that. So, but because I'm converting to dm³, right? I have to divide by 1000. So the normal formula for amount in moles is concentration times volume. If this is in dm³, now I'm not supposed to divide again. But most times it's always in centimeter cube because of the way our burette is being calibrated. So that's why I'm dividing like this. So the amount is now going to be, so what is the concentration? I've gotten that already. 0.0790 times what is the volume? This is the volume. 20.80 divided by 1000. So the amount will now be what? So that will be 20.80 times 0.0790. 20.80 times 0.0790, okay, divide by 1000. That's 0.00164 moles. I don't know if you are here. So please get it. They can ask you for, you know, they can ask you for amount of these two. It's possible. They can ask for amount of E. When they ask for amount of E, you are still using the same formula. Concentration, that would have gotten the concentration of E. Then what is the volume of E? Is already on our table. The volume of E is the volume of the pipette that we use. That's 25. Then you divide by 1000. You still get our answer. I don't know if somebody is still here. So very important. Just get that now. So 3. So if you ask amount, this is how you go about it. If you ask concentration of this in mole per dm³, that's how you go about it. So let's see. 3. Concentration of B in mole per dm³. Can you see that now? Concentration of B in mole. They did not ask you amount. They ask concentration. And if we go to the question, let's come back to the question, and that's where the technical aspect of this question comes from. They said E was prepared by diluting 50.0 centimeter cube of a saturated solution of this at room temperature to this. Do you see? So they have prepared a saturated solution of this one. It was 50.0 centimeter cube. They now added water to make it up to 1 centimeter cube. You know, by so doing, they didn't even tell us the concentration of the P they have prepared. So we need to look for it ourselves. So we use our titration formula. Now look at this. You know our titration formula is CA over CB VB equals NA over NB. Yes or no? But now, you know we don't have A and B now. That's why I said there's a little adjustment. We don't have A and B. What do we have? We have D and E. So instead of me to use CA, and I use CD, because that's D, they didn't say A. So don't make that mistake on that day. It's not A now. Because a lot of you say A is not A, you can't see A on that day. It will be D and it will be E. I don't know if that's clear. So we cannot change this to be C D. Can you see that? V D. Can you see that? Over C E V E equals N, right? D over N E. Please understand chemistry. That's why it's not stereotype. It's not stereotype. It's the question that will determine what you will do. That's what we do. It's the question that will determine what I will do. When I see the question, then I will know what I will do. And very important too, I think I just remember, for people that have been asking me about the qualitative analysis for this alternative B, I said it's the same with the video we have already done on the channel. And if you check the video before this one, I dropped a short video. Then when you check the comment box section, you're going to see the link to the full video for the qualitative analysis. So that should not be a problem. The qualitative analysis, we have even uploaded that for some weeks now. I think about 1 week now is there. So you can watch it. Check the video before this video. Check the comment box section. You will see the full. Watch the short clip to understand. Some of you, you don't watch this video. You just come and comment. So where is this? You just see the video. Just students are very funny. So please, when we post any video, watch the video. There might be a vital information you need to get that will lead you to another video. So watch that short video. There's an intro I did there to explain something. Then after that, check the comment box section. You see the link to the full video for the qualitative analysis. Then you watch that. I want to believe that is clear. Okay. So this is what we are using now. This is what we are using. So from here, let's go now. Concentration of D. Do you see that? Please pay attention to this. Concentration of D is in mole per dm cube. If you are using this formula, we are using them in mole per dm cube, not in moles. So don't go and say concentration of D is this one. You will be wrong though. That's the concentration in moles, not the concentration in mole per dm cube. So get it. So concentration in mole per dm cube is this. You can see boldly written here. So concentration of D will be 0.0790 times volume of D. That's our titer value. That's 20.80 over concentration of E. Can you see that now? That's what we're looking for. Sorry, it's not B. Sorry, it should be E. Very important. It's not B now, it's E. So concentration of E. That's what we are looking for now. So that will be CE times volume of E. Can you see that now? That's 25 equal to amount of moles of D. You come to the equation. Amount of moles of D. D is the acid, right? That's 2 over amount of moles of E. This is E, right? That's 1. Please note this. There is no A or B. That's why I quickly corrected this. It's E. You won't see A or B on that. So then we now cross multiply to make this the subject. So we have CE. We now do what? 0.0790 times 20.80 times 1 over 25 times 2. We must make this the subject. So from there we now have our CE to be. Let's now use our calculator. So we have 0.07. Sorry. 0.0790 times 20.0790, okay, times 20.80. So this one is 50 definitely. So divide 50. That will give us our C will be 0.0328. So that will be 329 approximately. More, you know, is always to two significant figures. So 3 significant figures rather. So that's how you get that. So you can see these things are simple. Now let's assume. I want to touch all aspects so that you will not go there and say, oh, I don't understand. If they not ask us, you know, they ask concentration of E in mole per dm. What if they ask amount of E? So if they ask amount of E, I'm using this formula, right? And what would that be? It will now be the concentration which I have gotten, right? That's if they ask amount of E. That is this concentration, which is this, times what is the volume? Volume of E, that's what? 25, right? Over 1,000. You get the answer. So if they even ask amount, that's the easiest. Very easy. So, but they didn't ask it, I'm just keeping that in. Okay, then the fourth one, solubility of NO2CO3 in mole per dm cube. Now look at this, in mole per dm cube. Because this is a saturated solution. Saturated solution means you have dissolved something, right? Of course, we know saturated solution, supersaturated solution, unsaturated solution. Those are chemistry terms. This is not a theoretical class, so don't let me do that. So now they want to look what is the solubility of NO2CO3 in mole per dm cube. Let's do it like this, very easy. E now that was prepared by diluting this, you get that now. So which means that for our 4, we can now say when they prepared this and they made it up to this, the number of moles that is actually there is what is this. So we can say 50.0 centimeter cube, okay, is equal to 0.0329 moles. I don't know if this is clear. So when they prepared this, when they prepared by diluting this of saturated solution of this, the number of moles that is there is this. So but they now ask us now solubility of this in mole per dm cube. Very important. Mole per dm cube. Meaning we are looking for the mole in 1 dm cube. And 1 dm cube means 1,000 centimeter cube. So we can now say 1,000 centimeter cube will now be what we get. So our X is going to be 1,000 times 0.0329. Okay? Over 50. So our X will now be, this is our calculator, 1,000 times 0.0329, okay, divide 50. That's 0.658 is 0.658 mole per dm. So which means if in 50 they have this, that means in 1,000. You know, they said that they made it up to what? To 1,000. You get that now? So in 50, they add this mole. So when they made it up to 1,000, it means the number of mole. There's just a simple mathematical calculation. That's simple. Okay, so from there now, so what do we now have? They said the mass of NO2CO3 that will be obtained by evaporating 1 dm cube solution to dryness. That one is simple. I think that will be, let me, you know, you already understand this table, so permit me to rub off this table. Then I'll just chip in 1 or 2 things and that will be all. So, wish you guys success. Just go over this video over and over again, share it to your friends. It will be better. Even if you have done A, even if you have done alternative A or you have done any exam, all these things are important. They are very, very, you are taking Japan. All these things are important. Very, very important. So now, the last one now, which is what? Mass of Na2CO3. Right? That will be obtained in 1 dm cube. If it is evaporated, that one is easier. If you are looking for the mass, what do we do? The mass will now be what? The mole times molar mass. It's just like making mass here the subject of formula. Get that? When you make this mass the subject formula, it becomes it. So we already know the mole. Can you see that? That we already know the mole in 1 dm cube. That's the reason why this is important. We already know the mole, the number of mole that will be in 1 dm cube, which is what? Which is this now. So we can calculate the molar mass first. Let's do that. Na2CO3. The molar mass will be, they are giving us the atomic masses. That will be 23 times 2 plus 12 plus 16 times 3. So that will give us 46 plus 12 plus 48. This, okay, that will give us 106 gram per mole. I want to believe this is clear. So from there, what do we do? Then we now have our mass. The mole now, that's 0.658. Abi? Times 106. So our mass is now what? So let's do our calculation. 0.658, right? So our mass will now be 0.658 times 106. Is that not? So 106 will now be, okay, times 106. That will be 69 point approximately 748. So since we have 3 significant grams, let's just say 7 grams. This is that 69.7 grams. Some people can still write gram per gram as this is the same thing. I don't know if this is clear. So the question can come in different formats. Just understand what we have been doing. Very important. Understand what we have been doing. It will save us a whole lot of stress. Understand what we have been doing. Go over this thing over and over again. I tell you, there is nowhere they can come from than all this angle. And I'm just keeping one other angle. I felt they can still, they can still test you guys on. I'm just repeating and that will be all. So very, very important. You need to understand that. Okay, so very important now. Please take note of this. Go over this thing. All this, these little changes, take note of them. Very important. So that's just all for this. If you are asked concentration in mole per DMQ, you know what to do. If you are asked amount, you know what to do. All this one, mass of this that will be obtained. So the mass that will be obtained, I think we're getting that, okay. So the mass that will be obtained is what? Is this. If you still put your per DMQ, you are still correct. You are still saying the same thing. What you are saying is that you have 69.7 grams in 1 DMQ obtained. Solution. So you are very correct. So anyone, so with this 69.7 grams will be obtained if you evaporate what? 1 DMQ. That's good. Okay. So I just love to be. Now let me keep in this. Very important. Let me keep in this. Now look at this. I just feel this is another. We are done with this one. I'm just trying to chip in this. Probably they can come in that way. Probably they can. So let's say, for example, the question comes like D is, let's say, 4.98 grams. I think I did that. Okay, per DMQ of HNO3, which is, I've done this on my channel before, but for people that are new to my channel, that's why I'm just chipping in this. Then we now said E is 1.75 gram in 500 centimeter cube of X2CO3. Can you see? They can come like this. If they come like this, then you have to do something with X. So very important. Let's now see the question. If it comes like this, it's possible. It can be 500, it can be 250, it can be 750, anyone. So let's now say the answer calculate. All other things remain the same. Our theta value remain the same. So let's say the answer calculate concentration of D in mole per DMQ, right? 2, they will say concentration of E in mole per DMQ, right? 3, they can possible because they can say molar mass or they say value of X. So and there is no way you are going to get the value of X. You must get the molar mass of this. So they can say 3. They can add it like this. 3. They can say molar mass of X2CO3. It's just to beautify the question. Even if this question is not there, if they are giving us, if they give us this value of X, you must calculate this before you get this. So what if the question comes like this? What do you do? This one is the same. If the question comes like this, it's even the simplest. How do we tackle it? Concentration of D mole per DMQ, the same thing. Concentration of D mole per DMQ, right? You have gotten that. If you go back to the video, you have gotten that, or look at that, I've not even erased it. So concentration of D in mole per dm, can you see? All these things will still follow the same cycle. Just understand titration. You will, no matter the way they actually bring the question, you will just play around with it. You play around. So concentration of D in mole per dm. Can you see we have gotten that already? So this is what is sorted. Can you see that? Very simple. Concentration of E in mole per dm cube. You see that? Concentration of E in mole per dm. Have we sorted that? Yes, my brother. This is it. Can you see? It will give us the same value. Now look at just the little difference between this question and the first one I did. Molar mass of S2CO3. You see, they boycotted all this one now. They didn't give you that. So, which means the third one, let's do little thing on that. So I said if this is the question, I need you to rub off this. You should have written this if you want to. Just keeping that, then that will be all for this video. I hope you're having a nice time on Chemistry Hangout. If you are new to this channel, this is the way we do it here. We make chemistry very fun, easy, and relatable. And that's what we do on this channel. So if you are a new, you are just watching this very particular video for the first time, or this channel for the first time, or you are new to this channel, click the subscribe button. Don't wait. There are videos we are going to be uploading. You don't need to miss out on those videos. So subscribe, share the video, comment, like it, and we will be here to give our very best. So let's go now. Okay, so molar mass of this, look at that, molar mass of this. So they have boycotted all that solubility, this, they don't give us that one. So molar mass of this. How do we get the molar mass? Can you see? How do we get the molar mass? We already know this formula now. Yes or no? So let's bring it here. So mole is equal to mass over molar mass. Is that not? Okay, so let's move on now. They now said, look at this. They now said, what is the mole? We have already gotten our mole. It's 0.0329, correct? So they now said mass. Let's go back to the question now. They gave us mass, E now. Because we are looking for the molar mass of S2CO3. S2CO3 is the E. They didn't give us Na2CO3 now, meaning they asked us to look for the X. So, molar mass of this will now mean that 1.75 gram in 500. Have you noticed something in chemistry? That they are always obeyed with 1000 centimeter cube. You can see no matter anything they give us, we must look for it in 1 dm cube because that's the standard measurement in the chemistry laboratory. Standard. That's the standard measurement. So now look at this. 1.75 gram in 500. It could be 250. It could be 750. We need to still convert it back to 1000. So let's quickly do that first. So we say 1.75 gram in what? In 500 centimeter cube. Don't forget, it could be 250, could be 750, could be 950. We are converting back to 1000. So in 1000, it will be what? It will be X. Right? So our X will be 1.75 times 1000 over 500. So let's see X now. Let's see X. 1.75 times 1000 divide 500. That's giving us 3.5. So we can have just say 3.50 gram, right? Gram per dm cube, right? So that is the mass now, gram per dm cube. So we have 3.50 gram in 1 dm cube. Sorted. Now we can now come back to this formula. So let's make this now. Can you see that now? Because they said molar mass of this. And I've told you, even if they did not give you molar mass of this, if they are giving you value for this, you must get the molar mass before you get the value. As simple as that. So let's make molar mass the subject now. So our molar mass will now become mass over what? Over mole. I want to believe somebody is still here. Chemistry is sweet, it's fun. If you are learning chemistry and it is boring to you, if chemistry is boring to you, please come to chemistry. If you are bored, come to chemistry hangout and catch fun. That's why we say it is an hangout. You know what we do in hangout? We eat and dine. We dine, we wine. So come and wine and dine with chemistry. So it should not be boring. It's interesting. It's interesting, guys. Okay, so let's move on. So our molar mass equals mass over mole. What is the mass now? You have gotten it. And that's why titration is very, very tricky. When you miss one value, the probability that you are going to miss all the value is high. Because the value you have gotten is the one you use to calculate and You know, you missed the first one. Oh, why? Oh, you're on your own. Okay, so the molar mass. So we have now that the molar mass will now be equal to, what is the mass now? 3.50 gram per dm cube over, what is the mole? We have gotten that now. That's the C, right? So that would be 0.0329 mole per dm cube, right? So the molar mass now. So let's see what the molar mass will go us. So 3.50 divide 0.0329. That's giving us 106.3. No, but we are going to 3 significant. So we can just 106.3. That's what it's giving us. So we can just say molar mass is 106 gram per mole. Please, that unit is very, very important. So after that, what do we do? Now look at how interesting chemistry is now. It's a value of S. I will just come and tell them that, okay, you want me to look for the value of S? Nice. So which means S2, okay, let me go, that's 4 now. So S2CO3, right, is equal to what? Which means the molar mass of all this compound is what? Is 106 gram per mole, right? So I can now say S2CO3 is equal to 106. So let's go now. X, we are looking for X. So that will be X times 2, Abi, plus carbon will be given in the question. That will be 12, plus oxygen will be given in the question. That's 16 times 3 equals to 106. Interesting? So this will give us 2x, right? This gives us 2x plus 12 plus 48 is equal to 106. Are you still here? Okay. So we have 2x plus 12 plus this, that gives us 60, okay, equals 106. Are you still here? 2x will now be our arithmetic now. 106 minus what? 60. Is that not? So, which means that 2x will now be 106 minus 60. Let me do that. 106 minus 60. That's giving us what? 46. Guys, that? Divide both sides by 2. Now we are looking for x. So, x will be 46 over 2. X will be 20 what? Which is the molar mass of sodium. So which means X is sodium. So this compound is Na2CO3. Simple, interesting, fantabulous. You are doing well. So you can see. So all these things, which means if they not go the first way, they can just give us the first 2 questions and divert to, you know, calculating this. It is still simple. It is still interesting. It is still the same. If you like this video, give us a like now. Give us a like. We are here to make these things very, very easy for you. So share the video, guys. Share the video. You know, comment, like. You know, we are here for you. We are here for you. We are doing every possible best to make sure that chemistry and other science subjects is very, very interesting. I wish you guys success. If you are new to this channel, don't procrastinate. Subscribe to this channel. Subscribe to this channel. Come closer. Come closer. Come. My video, please come closer. Come closer. Why don't you want to subscribe? Then give me one reason. You have been enjoying a whole lot of benefit from those videos, and you can see we have been trying our best. You know, sometimes all these reagents are not easy to come by. I need to tell you the truth. You know, but we have been trying to make sure that we do this thing practical. It's not like I would have released this video a long time ago. Yes, I released it a long time ago. But I believe in the practical so that we can show you the way it's actually going to look like. Peradventure, you are doing this same thing. You know, maybe you have reagents in your school and you are doing, though we know some of you, sorry. So, you know a lot of you, in your school there is no reagent. So we are just trying to, if a whole school cannot get reagents, and we are doing all our possible best to get reagents, at least we need encouragement. And one of the ways you encourage us is your comment. A lot of people have been reaching out to me. I sincerely appreciate your comment, your prayer. These are things that actually get us going. So we love you guys. If you are new to this channel, subscribe to the channel. And if you have been part of our Chemistry and God family, we love you. we cherish you, we celebrate you. And for my co-educators, you know, a lot of people have reached out to me. But if you are, you know, a chemistry educator or you're a chemistry enthusiast and you are actually still having one or two challenges about preparing laboratory reagents, you know, predicting all these questions that will guide students to success, you can reach out to me. We already have a packed video, fantastic video, around 500 chemistry educators have gotten access to it, and the review has been mind-blowing. So I will give all glory to God. So if you are a chemistry educator, you are a chemistry enthusiast, you are still having challenge with, you know, predicting questions, preparing laboratory reagents, getting the right indicator, a lot of things that revolve around practicals, then you can reach out to us so that we tell you what you need to do and you get the video to help you. Thank you very much. I love you guys. I love you guys. Don't worry, for people that have been chatting me as regards other videos, probably for NECO that is coming up, don't worry, we are going to do that too. Can you see? We're going to do that. It's an interesting practical tool for NECO, very interesting. In fact, it's because I saw the instruction, it's about similar thing with this. So that's the reason why if you are doing NECO, you are not doing alternative, you have to watch this video. You have to watch this video and prepare so that when I begin to predict the question for NECO 2, it will be a bit easier for me. Because in NECO 2, I think they are using sodium carbonate too. So which means in NECO 2, you don't now still expect me to come and be explaining how if the question comes S2CO3 to be explaining this. I've already done it in this video. But you know some students will not watch it on the day of the exam. Don't be like that. Change. Tell yourself I will change. Okay. So I love you guys. I love you. I'm just, you know, I'm happy to, you know, teach. These are one of the things that give us immense joy. Teaching people, impacting people, what we love doing. So I love you guys. Till we meet again on this channel, do have a wonderful day. Take care of yourself. I wish you tremendous success. This is Chemistry Hangout. Do share the video, like the video, comment, and subscribe to this channel. Bye. Thank you.